All right. So right above those problems, just to remind yourself, those are the steps that we take in factoring things. First thing we always want to do is take out the greatest common factor. Next thing we do is we count how many terms there are. And remember, terms are separated by plus and minus that are not in parentheses. Okay? And if there are two terms, we're going to follow these rules right here. Those are the three ways we can factor two terms. Okay, difference of squares, difference of cubes, and sum of cubes. And we went over these formulas quite a bit yesterday. And remember I said, regardless of the way you were taught, it would be better if you thought of these. If there's a negative here, a minus right here, that first factor is going to be a u minus a v. And then there's always one negative in each one of the formulas, and it's always in the middle. If it's not in the middle of the first one, it's got to be in the middle of the second one. If there are three terms, it might be a perfect trinomial square. Well worth memorizing those. Okay. If not, it's either going to be an easy type of trinomial because it starts off with just a 1x squared or 1m squared or t squared or whatever the variable happens to be. If not, it's a hard one. You can do that by guess and check, but trinomial grouping, okay, that technique that I showed you the other yesterday, that works really well, okay, really well. And also, if that technique doesn't work, you know for a fact it's prime. You don't have to guess 8 different ways and figure out, oh crap, it doesn't work at all, okay? And then if there are 4 or more terms, then we group them, and we group them to try and make them look more familiar. So we group them to try and make them look like one of these two right here, a group of 2 terms or a group of 3 terms. And then we always want to factor completely, and we want to make sure that we include every single one of the factors that we produced in the final answer. So you want to be really careful there. All right, so let's see. Brandon, what would we do on this one right here? Not on this one because we've got a fifth power and everything. Okay. There we go. First rule: always look for, is there a common factor in all of the terms? Okay. So the first thing we're going to do is we're going to take out a t. So if I take out a t, I'm left with t to the 4th minus 16. Okay. Destiny, what's next? What do we do with this one? What's that? So we took out a t. We're kind of looking at this right here. Is there a way to break that down anymore? So we already took out the greatest common factor. So what would we do next? Okay, look at your list there. After you take out the greatest common factor, what do you do next? You count how many terms there are, right? How many terms are there in here? Right here?
2.
There are 2.
Sorry.
Okay, t to the 4th and 16. Okay, there are 2 terms. Do I have to worry about 3 terms or 4 terms? Nope. This is the only thing it could possibly be. We already took out the greatest common factor, so that's the only thing that it could possibly be. Make that a little smaller so we can see them at the same time. Are these perfect cubes? They're perfect squares, right?
Yeah.
Okay. So it's going to be this formula right here. That's the one that we're going to use. Okay, so let's check and see. Is 16 a perfect square? Of what? Of 4. Okay. Is t to the 4th a perfect square? It is. Of what? T to the 2nd, t squared. Okay. So this one right here is going to break down into t squared minus 4, and I'm going to write that first, and t squared plus 4. Okay. Always want to keep track of that t right there. Are we done? Have we factored completely? Nope. Okay. Okay. Have I factored the t completely? Is there anything I can do with that? Nope. Let's take a look at this. T squared minus 4. We already took out greatest common factor, so you don't have to worry about the first one, that first step. How many terms are there in here? There are 2. If there are 2 terms, it could be a difference of squares, a difference of cubes, or a sum of cubes. Now, there's no way either of those are perfect cubes, right? So is that a difference of squares? Is 4 a perfect square? Of what? 2. And is t squared a perfect square? Of what? T. So this is going to be, there's the t that's out front. This is going to be t minus 2. This is going to be t plus 2. And then I've got this guy right here, t squared plus 4. Now, can I break that down any more? T squared plus 4. I see some shaking heads. Can I do this? Well, I guess a good guess would be, t plus 2 and t plus 2. It's a pretty good guess, right? Okay, raise your hand if you think that's the right way to break this down. Okay, I've got like 4.5 hands up right now. Okay, you can't break this down anymore. This right here, that whole thing, that's factored completely. Okay, and if we wanted to be more specific, we'd say it's factored completely over the real numbers. Okay, so let me show you why this doesn't have an answer. This would be a sum of squares. There is no sum of squares formula. Okay, so let me show you why this doesn't have an answer and why t plus 2 times t plus 2 wouldn't work. If I multiply the t's together, I get t squared. If I multiply the t times a 2, I get 2t. If I multiply the 2 times a t, I get a 2t. And if I multiply the 2 times the 2, I get a 4. So do I have a t squared? Yes, I do. I like that. Do I have a 4? Yes, I do. I like that. I've got this and I've got that. But take a look at those two middle terms. What do I get? I get 4t. This is a perfect square trinomial. Okay, it has a middle term. Okay, so I'm going to write this one more way and help make clear why difference of squares has an answer and sum of squares doesn't. So I'm going to write t squared minus 4, and I'm going to write it this way. T squared plus 0t plus 4. Oops, minus 4. Okay, so I'm writing this one right here. I'll write that one in red. And then I'm going to write this one in green. This one's going to be t squared plus 0t plus 4. I'm going to write them both as trinomials. Okay, now hopefully you're pretty good at factoring trinomials, especially this isn't even a hard type of trinomial, is it? This is an easy type because it starts off with a 1 here. So on this one, I'm looking for two numbers that multiply to be, help me out here, -4 and combine to be 0. Well, let's just think about that for just a second. Can you find two numbers that multiply to be -4 and combine to be 0? Logan? 2 and -2. So I'm going to put -2 here and 2 here. So do those multiply to be -4? Yep. And do they combine to be 0? Would they make 0t if we multiplied it all the way out? Yes, they would. Okay, that's why this is the right factoring for the difference of squares, t squared minus 4. Okay? Now, that would be kind of a silly way to do every single difference of squares problem, but you could do it that way if you wanted. You could write it as a trinomial with 0 in the middle, and you could answer that question that we normally do on a trinomial. Any questions there? Yeah.
Okay, so could you just, sorry about this, but could you just kind of clarify the very end, the last step pretty much of the t squared plus 4?
So why this doesn't factor anymore?
Why it's there, I think.
Okay, because this was t to the 4th minus 16.
Right.
It's got two terms.
Right.
It's a difference, and they're both perfect squares. 16 is a perfect square of 4. T to the 4th is a perfect square of t squared. So it's going to be this minus that, t squared minus 4, and then it's going to be this plus that, so t squared plus 4.
Okay, thank you
Is that okay?
so much. Yeah, that works.
Okay, let's take a look at this one here. So I should have changed colors. Let's take a look at that one. It's a trinomial. T here, and then I'm looking for two numbers that multiply to be positive 4, and they'd need to combine to be what? 0. How can you make a positive 4 when you multiply and a 0 when you add them together, when you combine them? Well, the only ways that you could make a 4 would be 1 and 4, -1 and -4, 2 and 2, -2 and -2. Do any of those make a 0 when you combine them together? Nope. Okay, you're not going to find any numbers that multiply to be 4 and combine to be 0. So this doesn't factor anymore. Okay, there is no formula for sum of squares. Doesn't factor. Okay? So that's why this whole thing is the answer. Any questions? I'm recording this, so if you have a question, you can go back and watch it again and think about the explanation, or better yet, you could just ask one right now. Everybody good there? Okay. All right, let's take a look at the next one. Okay, there's something kind of wrong with this. Nathan, what is it?
The minus 20.
Yeah, that should go in front there. It should be in, what did we call that order? Descending order. So we're going to write this as a squared minus 20a plus 100. Okay? And Lynn, what's the first rule in factoring? Do we have any common factors? Is there anything common to every one of them? Nope. Okay. So Sarah, how would we factor this? Put an a here. You do square that. Mm-hmm.
And then a plus 10 squared.
Is that right? Okay. Just that part is right. Okay? This is the right answer. I'm going to write that right answer over here, and we're going to talk again about why. There are two ways you could do this. There are no common factors. So after you take out common factors, the next thing you do is you count how many terms there are. How many terms here? 3. Okay? Look at that list of factoring techniques if you have 3 terms. Perfect square trinomials, easy trinomial, or hard trinomial. Okay? One of those has got to work. If it doesn't work, then it's going to be prime. You could do this thinking of this as an easy trinomial. So I could say this. I need an a here and an a here. And I need numbers that multiply to be positive 100 that combine to be negative 20. Multiply to be positive 100, combine to be negative 20. Miranda, what would those numbers be? Multiply to be positive 100, combine to be negative 20. Negative 10 and negative 10. If we just double check this visually, do these two multiply to be a squared? Yep. Do these two multiply to be positive 100? Yep. Those two multiply to be negative 10a, and those two multiply to be negative 10a. So if I have negative 10a plus negative 10a, what do I have altogether? Negative 20a. Does that produce the right middle term? Yep, it does. And what's the easiest way to write a minus 10 times a minus 10 since I've got a repeated factor? There's 2 of them. Just use an exponent. Square that. Okay? Any questions? Okay. Now, a technique that would be worth understanding and worth seeing how it applies on problems like this is try and see if you can figure out if it's a perfect square trinomial. The only hope it has of being a perfect square trinomial is if it starts with a perfect square and ends with a perfect square. So if this had been 99 on the end, is there any way this could be a perfect square trinomial? No. It's got to end with a perfect square and start with a perfect square. So, does it? Yep. A squared is a perfect square of a. 100 is a perfect square of 10. And then what we did with those is we multiplied them together. You got 10a, and then I take that number and I double it. What do you get if you double 10a? You get 20a. So does this fit that perfect square pattern? It does. So I'm going to take that variable, that expression right there, that number on the end, 10, I'm going to put a square on it, and how do I decide what sign goes in between them, whether it's a plus or a minus? Tammy? Yeah, it's the same as the sign of that middle one, okay? Do you see why when I asked you to memorize some of these formulas, I say take a look at what that middle sign is? That middle sign many times is really important. Any questions? Okay, got to be in descending order before you start factoring it. That's going to make life a lot easier. Okay, let's take a look at the next one. Cameron, how would you do that one? So we're on C. And is there a greatest common factor here? No greatest common factor. Okay? So Tony, is this a binomial, a trinomial, or does it have more than that? It's a trinomial. Okay? So next thing we check is, does it start with a perfect square, Tony? Nope. Okay? So there's no way this is going to be a perfect square trinomial. Okay? What technique are we going to use? Okay, is this the easy type? Tell me why. Yes or no?
No, because
Okay, it's not a 1x squared. If it's not a 1x squared, it's going to be more difficult. Now, again, I said if you're good at guess and check and can figure this out without doing that grouping technique, that's totally okay. Some of you are probably pretty good at factoring. If you're not, Tony, I'm still picking on you. What do I do to solve this using that grouping technique? Yep, and how do I do that? What would I do to solve this problem? See, I'm putting you on the spot here. If you have a test on this in 2 weeks, are you going to know what to do? Okay, somebody want to help her out? Who can help her out? What do we do to factor this? Raymond.
You times the first 5 with the second 5.
Okay. You times this coefficient, including its sign, with this coefficient, or this constant, including its sign. So I'm going to take these two numbers and multiply them together, and I'm going to write it over here. So when I multiply them together, I get a positive 25. And I like saying and writing the sign. Now what I'm looking for is I'm looking for two numbers that multiply to be positive 25 and combine to be this number right here. So we need numbers that multiply to be positive 25 and combine to be negative 26. Multiply to be positive 25, combine to be negative 26. Jordan, what have you got?
Negative 25 and -1.
Very good. Okay, now, please do yourself a favor. Double check right here. It's a lot easier to check right here because if we got this right, we're going to get the problem right. From here on, it's not that difficult. Okay? Do these multiply to be a positive 25? Yes, they do. Do they combine to be a negative 26? Yes, they do. So we're going to get this right. So here's what we do from here on out. I write that problem again. And the only thing I do differently is I take that 26 and I write it as these two numbers that I had right here. So I'm going to write minus 25x and I'm going to write minus 1x. Now, if you don't want to put the negative 1 in front there, you do have to put the negative. You don't have to write the 1. I like that just because it's a little bit more explicit. You can actually see where we're using those numbers. Okay, are there any questions? Okay, Callie, how many terms do I have in this polynomial now?
4.
I have 4. And how do we factor 4 terms? Group them, okay? So which ones are we going to group together?
The 5x squared and 25x.
Okay, so I'm going to group these two together, and I prefer doing kind of a little arcing little circle down here to show that. Okay, don't use parentheses to group them together because parentheses mean something mathematically. All right, so what can I take out of this first group, Callie?
5x.
Take out a 5x. Now let's think about this. If I take out a 5x, I took out the 5 and I took out one of the x's. Logan, what's left? X minus 5. Very good. Okay. I took out the x and I took a 5 out of 25. That leaves a 5. And notice I took out a positive, so it doesn't change the sign of either one of those. Any questions? Okay. Noah, what can I take out of here?
-1.
Okay. You have to take something out. And you always take out the leading sign, so we're definitely going to take out a negative. And if they don't have anything in common, everything has a common factor of 1, so we're going to take out a -1. And that's going to make this what, Noah?
X minus 5.
It is. When you take out the negative, pulled out a negative, if I take a negative out of a positive, it changes to a negative. And if you're ever wondering, and this is the cool thing about having factoring problems on a test, if you're not sure you got it right, you can multiply them together and see. So if we factor this correctly, if I multiply through, this should be a negative 1x. It is. And what is a negative 1 times a negative 5? Positive 5. So did we factor that part correctly? Okay. Tara, how many terms do I have now? I only have 2 terms. I have this term and I have that term. Remember, that minus right there is outside a set of parentheses, so it breaks it into this piece and this piece. Okay? So what do I do? Okay, and it doesn't matter how you write it. She said 5x minus 1 and x minus 5. That's totally okay. If you wanted to say, hey, I'm going to pull out the x minus 5, and what's left of this one right here? A 5x, and what's left of this one right here? A minus 1. Both of those are okay. Can somebody tell me why both of those are exactly the same? Peyton? It's that property that says you can move things around. Does anybody remember the name? Raymond? Commutative. Okay? You can move things around in a multiplication problem. You can take this factor and switch it with that factor. Okay? Change the order of the multiplication, and you still get the same answer. Okay? So either one of those are okay. I'm going to leave it like this. We do normally write the one with the bigger coefficient out front. Any questions there? Sure? Okay. All right. Okay, this one has an asterisk by it. Can somebody tell me why? What's that? It's kind of important. It's kind of a nasty problem. They snuck a few of these in there. If you had to factor a trinomial, would you like factoring a trinomial with a fraction in it? No. Okay, not very fun. Okay, so on this one thing that you can do to sometimes make life easier, or at least to see whether or not it factors, is you can take out the fraction. Let's pull the fraction out front. So if I do that, I'm going to have a 1/3, and let's write down what's left. If I take a 1/3 out of this, what's left? X squared. That's great, isn't it? Okay, now, factoring out, if you don't remember this or haven't been taught, factoring out is like dividing out. So if I factor a 1/3 out of 1x, I didn't take out an x, so there's still going to be an x left, but it's going to change the number. I'm taking 1 and I'm dividing it by 1/3. How many thirds are there in 1? Or in other words, how many times does 1/3 go into 1? Goes in 3 times. So this is going to be a +3. Just a quick review on complex fractions. If I divide 10 by 1/3, remember you never divide by a fraction, you always flip it over and you multiply. So this would be 10 times 3. So what's this number turn into? Turns into a 30. Now, if you weren't sure about that, you say, you know, I think Mr. Laws is smoking crack and he has no idea what he's teaching us up there. There's no way that 10 turns into a 30. This is a factoring problem. How could you check to see that I got it right? Distribute through. What's 1/3 times x squared? 1/3 x squared. What's 1/3 times 3x? 1x. What's 1/3 times 30? 10. So did we get it right? Okay, now look at this. Destiny, how many terms in here? 3. Easy. Okay, it's not a perfect square trinomial because 30 is not a perfect square, right? Okay. Easy or hard trinomial? Yep, because it starts off, now we have a 1. That's a lot easier to work with. So we're going to try something like this. We're going to look for numbers that multiply to be positive 30, multiply to be positive 30, and combine to be positive 3. Well, let's see. We could run through a list. 1 and 30, 2 and 15, 3 and 10, 5 and 6. They'd both have to be negative, otherwise, if they were going to multiply to be a positive. Are any of those going to make a positive 3? Nope. So, what do I know about this right here? Okay, that polynomial is prime, and this whole thing, we've completely factored it. The only thing we could do on that is pull out a 1/3. Any questions? Okay. Let's see. Who haven't I picked on yet? I think I've got everybody, haven't I? Tammy, have I picked on you yet? Let's pick on Tammy for just a second, shall we? Tammy, how do you do this one right here, part E? What's that? Factor out an x. Say that again. No, I think you're right. Factor out 4 x's, or in other words, factor out an x to the 4th. Should we do anything else with this? Maybe rearrange it. So let's do this. Let's write this as x to the 6th minus 49x to the 4th. Okay, and then Tammy's idea was, well, each one of them have at least 4 x's, so let's take out an x to the 4th. And if I do that, I'm left with x squared. Took out all of those, so that's the 49. Now, I want you to finish that, and I want you to check with your neighbor and see if you got it right. So we've got x to the 4th, x squared minus 49 as one factor there. Take a good look at that. That should look familiar. Check with your neighbor, see if you both agree. If you do, you're probably in good shape. You're good? Brandon, what'd you get? Excellent. Even set it in the right order. Okay? This is a, whoops, that should be a 4. This is a difference of squares, perfect square of x and perfect square of 7. So it's going to be x minus 7 and x plus 7. That is factored completely. All done with that one. Okay? Any questions there? Okay, Callie, what would we do on this one?
You try to find something that, or like factor down the times together equal -20, but add together equal 1.
Okay, and is this, so there's no common factor, right?
No.
Okay, no common factor. Is this an easy trinomial or a hard one?
Hard.
Okay, a hard one. Can we just do this and be looking for numbers that multiply to be -20 and combine to be +1?
No.
No? Okay, so because we'd have to have maybe an 8m and an m over here. That might be one way to do it. Or maybe it's a 4m and a 2m. And then we've got to find numbers to put here that multiply to be 20. So if you're really good at guess and check, you could try it that way. Or because this is a hard trinomial, we're going to multiply 8 with -20. What do I get? -160. -160. And I'm looking for numbers that multiply to be -160 that combine to be +1. Now, I don't know a lot of numbers just off the top of my head that multiply to be 160. So there's no way it would be these two numbers though, right? There's no way we're going to make a 1 out of those. 2 goes in there 80 times. 4 goes in there 40 times. 5 goes in there how many times? 32. 6? Nope. 7? Nope. 8? 8 goes in there 20 times, but you can't make a 1 out of those. 9? 10? 10 goes in 16 times. 12? 13? 14? These are all of them, right? Is there any way, even if we made I mean, you have to make one of these negatives so they multiply to be a negative. Is there any way to make a 1 out of any of those combinations? What do you know about this then? You know it's prime. Okay? Okay. Tara, how about G? What would you do on G? You could group it. Okay, why would we group it for sure on this one? There's 4 terms, okay? And how do you want to group it? Okay, so first 2 here and last 2 there. We don't always group them this way. Sometimes we'll group the first 3 and leave the last one alone, but a lot of times we do it this way. So Tara, what do these have in common? So take out a W, I'm left with X minus Y. Okay, Tony, what would I take out of those 2? I'm going to take out a Z. And a little more specific than just a Z. What else am I going to take out? Very good, negative. And we're going to write that sign, and I'm left with X, because I took out a negative and a Z. And if I take out a negative Z, this turns this into a what, Destiny? A negative Y. So I've got X minus Y and W minus Z. That minus that we write right there. A lot of people don't write that, and they don't write the plus. That's important because it's the sign that goes right there. Okay? So we're in good shape on that one. All right. Let's take a look at this one right here. Peyton, what do we do on this one? What's the first rule? Even before that. Even before difference of squares or difference of cubes or anything like that. Greatest common factor. Okay. Are there any common factors here, Peyton?
15, well, you could divide them by 5.
Okay, so you can take a 5 out. So I'm definitely going to be able to take a 5 out. Anything else, Peyton?
X.
I'm going to be able to take out an X. Okay, and normally, this is already written in descending order and everything, but normally we're also going to take out the leading sign. So we're going to take out a negative 5x. So I took out the negative, took out a 5. What's left of the 15? Because we're dividing, that's going to be a 3. And I'm left with an x cubed, right? And if I took out, well, let's see, I took out an x, I took out a 5, so that's a 2, and I took out a negative, so it changes the sign of each of those, so that's going to be this. Okay? So we've successfully factored out the greatest common factor. We've got something that's still in descending order, and it starts off with a positive coefficient, so that's good. Hop, how many terms here? 2. There are only 3 ways to factor 2 terms. Once we take out the greatest common factor, it's got to be a difference of squares, difference of cubes, or sum of cubes. You have to know those. It's a difference. There's no way it's a sum of cubes. We can check that off our list. Is that a perfect square? Nope. It's not a perfect square. Is it a perfect cube? Okay. Both parts of this have to be a perfect cube. Now, x cubed is clearly a perfect cube. But is 3 a perfect cube? It's not. So because that's not a perfect square and not a perfect cube, guess what? We're done. That's all you can do with that. Not a very pretty problem. Okay. Logan, this one, what would we do? Okay, and you can take out a P. Are we concerned with anything else here? Okay, so this is going to be a negative 64, P to the 3rd. Okay, I would normally do this. And then I'd take out a negative P, which would make this negative P, and then I'd have 64P to the 3rd minus 1. Just because, now these are the same thing, they're just off by a negative. That's in a different order than this is, but that's okay because we factored out a negative. I would normally do that just to have it in descending order. Does it make any difference? Doesn't make any difference. Let's do it this way, since Logan started us off that way. How many terms right here? There are two. Perfect square or perfect cube? Perfect cube. This one's got to be a perfect cube. This is a perfect cube of 4p. 1 is a perfect cube of 1. Okay? So I'm going to write the p out front, and then remember that formula. It's going to be the 1 and a 4p. How do I decide what sign goes in between these? It's the same as that one. So it's going to be a minus. What do I know about all these guys in here? They're all positive. They're all positive. Okay? Because remember, there's only one negative in each one of the formulas. All right? So this is going to be 1 squared. This is going to be 4p squared. So that's going to be 16p squared. And how do I get that middle term? I just multiply them together. So that's going to be a 4p. And that right there would be factored completely. Okay? Any questions? Okay. I'm not going to do these two. I don't think they give you any like that. Occasionally we'll run into something like this. We probably cover a technique for this later on in the course. It's called the substitution technique. You can do this the long way. Okay? But here's what I'd like to do right now. I had a couple people come up and ask me questions. I had one person email me a question. So I want to make sure that we know how to do the problems on the assignment. So I'm going to open up the textbook.
There is one of those long problems on the assignment.
Is there? Okay, we'll take a look at it. What number is it? Do you know? Okay. What page is this on? 35. Okay. So I asked a couple people, make sure we take your questions. So let's look at 157, this one right here. Okay. It's actually, in my opinion, it's actually easier than this guy right here. Okay. So let's look at 157. So this problem right there. Raise your hand if you think you know how to do it. 1, 2, 3. Okay. That looks really ugly. Okay. Even as ugly as that looks, everybody here should know the first rule in factoring. What is the first rule in factoring? Take out greatest common factors. Okay. So take a look right here. Here's the first term, and here's the second term. Do they have anything, any factors in common? This has a 3x minus 2 or plus 2 quantity squared. This has a 3x plus 2. It's got just one of them. This has an x minus 1 quantity squared. This has an x minus 1 quantity cubed. So couldn't I take out a 3x plus 2? And what else can I take out? I can take 1 minus x. How many of them? 2. I can take out 2 of them. Now let's write down what's left. Did I take out the 7? Nope, so I still have a 7. How many of these did I take out? Just one of them, so I've still got 3x plus 2 left. And how many of these did I take out? 2, so I don't have any of them. So the only thing left of that first term is a 7, parentheses, 3x plus 2. And now let's turn our attention to this one right here. I took out 3x plus 2. Took out one of them. Nothing left of that one. A 1, if you wanted to think of it that way. How many of these did I take out? 2. So how many are left? Just 1. So I'm going to write the plus right there. Write the plus. And then I'm going to write down 1 minus x. So I've got 3x plus 2. I've got 1 minus x, quantity squared. And then let's write down what we've got right here. What do I do with this mess? Very good. Distribute the 7. 21x plus 14 plus 1 minus x. And let's just calculate what we've got here. 21x minus x, 20x, 15. And am I done? Almost. Really close to being done. What could I do with this one right here? Take out a 4. So pull a 4 out front, and I'm going to change colors. Oh, sorry, 5. Pull out a 5. What does that change this to? A 4, and changes this to a 3. Okay? That's not too bad, is it? Once you see how it's done? Okay. There was one, yeah.
Would it be 4x still?
Yeah, it would be, 4x. Yeah, I just crossed off the 20. Thanks for pointing that out. So this is what I'd have there if I wrote it all out. Good there? Okay. Somebody else asked a question on, was it 192? Okay. Let's take a look at 192. Okay. I'm going to give you a hint, and I want you to think about this over the weekend. Okay. When you walk in, so have a great weekend. Okay. When you walk in on Tuesday, you should be done with P3, and you should have read P4. Okay. So we're a day behind, but everybody clear on that? Done with P3, read P4. And if there's stuff in here that you're like, you know, Mr. Laws, I really don't know this stuff very well. I'm a little concerned about this. Please send me an email or come and talk to me, okay? Okay, I want you to spend some time thinking about that and come up with a number example on this one. Like, come up with a polynomial that has a degree of 2 and a degree of 3 and add them together and figure out the degree of the whole thing, okay? Question?
Yeah, there's that one more,
181. Oh, this one right here? Okay. If you don't know how to find the area of a circle, there are some formulas in your book. And you could also just Google how to find the area of a circle and look at some examples and try and figure that out, okay? Everybody understand what you need to do over the weekend? Okay, thank you.